The factorial is a mathematical operator that, while it comes up in several different places and while you might be familiar with it, is actually very intimately tied to the problem of counting or combinatorics. And so the use of factorials comes up all the time in counting problems, and being comfortable with factorials is a really important skill for dealing with these style of combinatorial problems. So really with the factorial, what we're thinking about is that it's going to give a mathematical shorthand for counting the number of orderings of distinct objects. So what do we mean by that more formally? Well, to motivate the factorial, let's consider a situation where we have 10 different books, we want to put them on a shelf, and we want to put them on a shelf in some set order. And so we can think about, well, how many different orderings are there going to be of these books on the shelf? And one approach we might take to this is to recognize that we could use the product rule for counting for this, right? Because you're going to have 10 options for the first book that you put on your shelf, and then you're going to go back to your stack of books and there's 9 left. And so then you're going to be able to take one of those 9, right? So you have 9 options for the second choice, and then you're going to have 8 options for the third choice, and so on, right? And so if you work through the product rule for counting, you can actually work out how many different ways are there of organizing the books on the shelf here. So in place 1, we have 10 choices. In place 2, we have 9, and so forth, right? So then we take n1 times by n2 times by n3, and so forth, up to n10, which is 10 times 9 times 8, and so forth, all the way down. And if you do that, you're going to find that there are 3.628 million possible options, right? 3,628,800 total options. And so there's a few things to note here. The first is that this is quite a large number. And I don't know what your intuition would have been if we had said, well, how many ways do you think there are going to be to place 10 different items on the bookshelf in order? But the thought that there are 3.6 million of them, or more than 3.6 million, is a little bit mind-blowing to me, right? If you have 10 books in front of you, it sort of seems like you should be able to test out all the different orders. But in fact, there are 3.6 million of them. You're not going to be able to test out all of the orderings of the 10 different books there, right? So that becomes very large very quickly. And these combinatorial problems are often going to bump into these huge numbers very shortly. And so as a result, we tend to want to have shorthand ways of writing these numbers down. The other thing is, if we notice what we've actually done here, we've actually multiplied all of the numbers starting at 10 all the way down to 1. And this is really what the factorial is going to do. So we have the product of all numbers from 10 down to 1. If there had been k total books, we would have had the same pattern, except instead of starting at 10, we would have started at k. And so what do we define the factorial to be? Well, the factorial is going to be the mathematical function that returns the products of all numbers from our given number down to 1. So if we have a positive integer k, then k factorial is going to be k times k minus 1 times k minus 2, and so forth all the way down to 1. Thought about combinatorially, k factorial is going to give the number of ways that we can place in order k distinct objects. So if we have 10 books, 10 factorial tells us how many ways we can order those. If we had 8 books, it'd be 8 factorial. If we have 80 books, it's 80 factorial. Right? Ultimately, as we saw, this derives from the product rule for counting. So the factorial is really just a shorthand for the product rule for counting in this situation where what we are actually counting up is the number of orderings that we have. It's also important to notice that the factorial of 0 factorial, is going to be defined to be 1, right? So 0 factorial is not actually equal to 0. And so there's a couple of ways that you can think about this, but the most intuitive way of thinking about this is the fact that if you have 0 objects, how many ways can you put them in order? And the answer is going to be 1, right? There's nothing there, but that's still the way that you can do it, right? If I tell you order everything that's in my hands right now, well, it's already ordered, and there's exactly one way of us doing that. Okay, and so by definition, 0 factorial is going to equal 1. Right? So how many ways can you arrange 0 objects? There are exactly one way to arrange 0 objects. So let's think about some examples that use the factorial in this way. We're going to consider a standard deck of 52 cards, and we're going to ask how many orderings are there of a single denomination, right? So we have aces or kings or whatever. If we just pull out the 4 aces, how many ways are there of ordering these? Right, so we have 4 objects, we want to order them. The answer is going to be 4 factorial. So that's 4 times 3 times 2 times 1, or 24 different orderings. How many orderings would there be of a single suit? Now there are 13 cards in any given suit, and so if we wanted to order all of the spades, how many ways can we do that? Well, there are 13 items we're going to order, so 13 factorial. 13 factorial gives us a number that is over 6 billion here. And so because this number is over 6 billion, we see that very quickly these numbers have gotten to be sort of excessively large, right? 6.3 billion, or 6.2 billion rather. Okay, and so 13 factorial is sort of a huge number. We can ask how many orderings are there of the 3 face cards, right? So we have jacks, queens, kings of each suit. And so there are 4 suits of each card, so that's a total of 12 cards, right? So we're going to have 12 factorial, which gives us our 479 million here. How many orderings are there of the full deck, right? There are 52 cards in the deck, so the total number of orderings is going to be 52 factorial. Now, 52 factorial is a number that's way too big to write down here. Well, I could write it down, but it'd be in small text, right? It's 8.07 times 10 to the power of 67. So we're looking at something that has about 67 zeros on the end of it. Okay, and so this is an absolutely massive number. It's sort of incomprehensible to all of us. And so the number of ways that you can order a deck of cards is going to be just huge, right? There's sort of no way of comprehending that number. But of course, we can still think about that through the use of our factorials here. So factorials really, if we're thinking about their main utility, is they provide a shorthand for enumerating the orderings of objects. They're going to be really helpful because, as we've seen, factorials get really huge really quickly. And so instead of writing down, a number with 67 zeros on it, we write 52 factorial. They're quite exciting to write down, right? We're using our exclamation points there, and so they sort of liven up the algebra that we're doing here. And so as a result of them being this useful way of enumerating the orderings of objects, they're going to arise frequently in counting problems. And so getting comfortable with factorials, using the factorial button on your calculator, but also being willing to just express things in terms of factorials is going to be a very useful skill as you begin to work through combinatorial problems.